Okay, now we look at on example 1. So how we use truth table in order to show whether the given statement is tautology, contradiction or contingency. Okay, so let's say given to you this statement. So we have not P and P implies Q if and only if not P. So in order for us to use truth table, first you need to determine how many variable or statement that we have here. So we have P and Q. So the number of row that we should have is 2 power the number of variable, right? So 2 power 2, so which is 4. So we should have 4 number of rows in constructing our truth table. So since the variables are P and Q, so we divide equally between a true and false. So that's why we have true, true, false, false. And then between the true itself, for the first 2 rows, so we make it true and false. So we alternately make it true and false. Okay, and then we construct the next one, so which is not P. So not P is the negation of the first column. So we negate. So if true, then it becomes false. If false, then it becomes true. Okay, then we construct for P implies Q. So P implies Q is the implication. So remember that for implication, it will be only false when the first statement, so in this case is P, is true, and the second statement, so in this case is Q, is false. The rest will be true. So you can see here we have true implies true is true, true implies false is false, false implies true is true, and false implies false is still true. So that is for implication. Okay, then we take out all the statement on the left hand side. So we combine it with N. So we take the third and the fourth column, right? So we find the N. So F and false and true is false. So for N, conjunction N, so it will be only true if both statements are true. So the rest will be false. Okay, and then we find the biconditional. Right. So this is actually biconditional. Right. So it should be conditional. So for biconditional, both statements should have the same true value. Right. So we have we compare the fifth column and the third column. So if both columns have the same true value, so means that it is true. So false, false, then that's why it becomes true. False, false, it becomes true. True, true is true. True, true, and is true. Right? So so now we have finished with all the statement, right? The given statement. So we can see that on the last column, we have all true. So from there, so we can conclude that that statement is tautology, right? To represent all true.